Hi, my name is Nicholas Manchester, and I completed my numerical calculation on finding the spring stiffness of a single atomic bond. This is the problem. And this is the code. The first section just copies the question. The second question initializes the variables in the question. D represents the distance between the center of each atom. L represents the initial length of the wire. Wire side represents the length of one side of the end of the wire. M represents the mass of the object hanging from the wire. S represents the change in the length of the wire. And G represents the acceleration of gravity. First, we find the stiffness of the wire, which equals force represented by M times G divided by S. Then we find the surface area of the wire by squaring wire side and the surface area of a single atom by squaring D, and then dividing a wire by a atom to find the number of atomic chains in the wire. Then we find the number of atomic bonds per chain by dividing L by D. Finally, we find the stiffness of each atomic bond is K wire times N bonds, all divided by N chains. Using this, we find that A is the stiffness of the wire, B is the number of chains, C is the number of bonds per chain, and D is the spring stiffness of one atomic bond.